Welcome to Khetz tutorials, and in this video I'll be doing question 13 from 1.3 exercises in James 2 calculus. So you're asked to start with the standard trig function that we know, and here we have cosine. So if we start with that, then let's see what we have. So we're just going to do rough sketches. We're not going to use actual points, but we're going to explain what happened to it. So your cosine would perhaps look something like this. And it would cut at 1 there. Okay, so this is a sketch. Basically, this is what it would look like. And now, let's look at this, starting with the 2. So the 2 now multiplies the y, which is the whole function. So now, let's take it in steps. Let's say this red one is cosine of x. If we were to multiply that by 2, then we're going to have this function, 2 cosine of x. So it's nice to take it in steps so that you can understand everything. So if this is at minus 1 and 1, then 2 times of that, which is this function, would now essentially be the same thing, but the amplitude is now twice of what you have. Well, my sketch is not precise, but you just have to understand that we're now at 2 and minus 2. So the amplitude has actually been increased, or we have stretched the graph vertically by a factor of 2. So that's the one transformation we've dealt with in that. Let's deal with this one. So the period of your cosine function is, so the normal cosine function is 2 pi, which is 360 degrees. And now, if you ever have a number here, that would affect the period. So you're going to have this divided by k. So imagine a k there multiplied by x, or any other variable that you have. In this case, we have an x. So you're going to divide your period by that number. So in our case, if we're now going to have this, then that means that the new period here is 2 pi over 3. Which is much smaller than 2 pi. This means that your graph is faster, or it completes a cycle faster. That's what it means. So it has more cycles in 2 pi than the one that only has one cycle in 2 pi. Because 2 pi is greater than 2 pi over 3, and you have some 2 pi over 3s inside 2 pi. So you have 3 of them, essentially. And now, that should tell you that this has been compressed 3 times, or you can get 3 cycles in the space that you'd only get 1 cycle for this. So this would be much, much faster, and there would be 3 of them in the time that you get 1. So from there to there, that's 1 cycle. And you should know now that you're going to get 3 cycles of this that has an amplitude of 2. So it has an amplitude of 2 now, and it's much faster. There are 3 of them in the space where you expect it to get 1. So now that just has 1, and you're supposed to fit in 3 of them in here now. So that would be 1, I guess, then 2. So yours would definitely be much neater. So that'll be 1, I guess, then 2. Then finally 3. So 1, so that's actually 2, that's not 3 of them. So you would sketch it in such a way that you get 3 cycles. I'm going to try again. So that's 1 cycle until you reach that point. And that's another cycle until you reach that point. And finally, we're going to squeeze in another cycle that would be something like that. So that's the point. So you now have 3 cycles in the space where you usually had 1. And that's what you should do. So whenever you have a function, it's important, or it can help you if you just take it in steps. Apply the first transformation, which is stretching it by a factor of 2. Then figure out how this affects your period and the number of cycles that you're going to have. So in this case, you'd have 3 cycles in the space where you'd normally have 1. So the result is then a function which has 2 times the normal amplitude of a cosine, and it has 3 cycles in the space that you'd normally just get 1 cycle.